Hello guys, so we are back again, and in this session we are going to start with a new topic of partial differentiation, which is homogeneous function. So what is homogeneous function? First you need to understand that, but before starting with the session, hope you have subscribed our channel Omega Pi ITG and get so that we can bring more engineering content to you guys. Now let's start the lecture with a topic of discussion of what is homogeneous functions. Till now you have heard this word, okay, in your smaller classes, but till now if you have means you don't have any fixed, okay, particular idea to verify what are homogeneous, but you will know that one thing which have been taught to you in old classes, that sum of the degrees is constant, sum of the degree power is constant. What does it mean? Okay, if I take a function ux comma y, suppose it is x power 4 minus 3x square y square plus 7 xy cube. Here you can see its power is 4, x and y compound power, okay, the terms are different but the power is 4. Here also the power is still 4, 1 plus 3 4, so the power remains, so the degree of the terms, the power of, okay, let me write the power of each term remains constant. This is what you have learned in your previous, means in your old classes, when we come across homogeneous function, right? And this is correct, that the power remains constant. Here is power is 4, here also sum of power is 4, here also the sum of power is 4. Now if I give you a equation, okay, a function, and tell you to verify whether it is a homogeneous function or not, so there is a process, okay, which you will learn something new, the extra which you will learn, that if any function is a homogeneous function, so from now onwards I will represent homogeneous function by HF. If any function is a homogeneous function, it should satisfy the condition. What condition? I will tell you what condition. The condition is, if there is a function f of x comma y, then for it to be HF, homogeneous function, okay, it should satisfy this. F of lambda x minus lambda y should be equals to lambda power n f of x comma y, where n is degree. Now we will take some examples and we will let you know from those how to identify, okay, it is a homogeneous function or not, okay. But you should keep this thing in your mind, this is very important. This is the means this you will continuously use in this topic of homogeneous function, this thing, that f of lambda x minus lambda y equals to lambda power n f of x comma y. This is very important and you should keep this in your mind. Now let's see the first question which we will see here. Verify u of x comma y, which is a function x power 4 minus 3x square y square plus 7xy cube, is a homogeneous function of degree 4 in two variables x and y. And this is the same question which you have just taken. What is the process? The process is that you have to write x comma y. First write the question whatever they give you, okay. We are now started with question, okay. This is just for the understanding of homogeneous function. What you have to do, replace x by lambda x and y by lambda y in u of x comma y, or you can say put x is equals to lambda x and y equals to lambda y in u of x comma y. Both are correct. Now what we are going to do, we are going to substitute. If I substitute, I'm going to get lambda x minus lambda y is equals to, if I take here, it will be lambda x power 4 minus 3 lambda x the whole square lambda y the whole square plus 7 lambda x into lambda y power cube. Here you can come to know the power, lambda power will come outside, minus 3 x square. Here lambda x square will again combine and become lambda power 4, which will again come outside, y square minus 3. Here 7 was there, 7 lambda and lambda cube will again combine and become 4, so lambda power 4 will also come outside from here, so we are going to get y cube. So if you observe, this is nothing but u of x comma y, so I will put here u of x comma y. So you can see that this satisfies the condition which we have just mentioned earlier, that u of lambda x comma lambda y, f of lambda x comma lambda y is equals to lambda power n f of x comma 4. So which here lambda power n is, okay, lambda power here, okay, here u of x comma y is a homogeneous function of degree 4 in variables. You can say this line of variables x and y. So in this way you have to verify. Okay, if it doesn't comes out, okay, lambda doesn't comes out or doesn't cancels out, okay, then it is not a homogeneous function. We will also see those examples, but for the timing you must have understand how to verify that it is a homogeneous function or not. Let's take some example for verification of homogeneous function. So the second example which we are going to take is this, and we are going to do it now fast. First, what is our job? Write the things, okay, y comma z. Let me read the question, otherwise. Verify that g of x comma y comma z equals to x cube y cube z cube by x square plus y square plus z square is a homogeneous function of degree 7 in 3 variables x, y and z. We are going to write this thing. Right, we have done this. Put x is equals to lambda x, y equals to lambda y, and z equals to lambda z. If you do that, you are going to get g of lambda x, lambda y, lambda z is equals to lambda cube will come outside from here, here and here, which will become what? Lambda power 9. And here it will be x cube, y cube and z cube as it is. It will be lambda x the whole square, lambda y the whole square, lambda z the whole square, which if you simplify you are going to get lambda power 9 into x cube, y cube, z cube the whole power. Lambda x square will come outside here, x square plus y square plus z square will be left there. This will, okay, this you will move up, you will be left with lambda power 7. This is what g of x comma y comma z. So here we have proved that g of lambda x comma lambda y comma lambda z is nothing but lambda power 7 g of x comma y comma z. So g of x comma y comma z is a homogeneous function of degree. How to check degree? Check this power, degree 7. Now let's move on to the next example of homogeneous function. The next example of homogeneous function is this one. Verify that f of x comma y equals to log x cube plus 4x square, f of x log x cube plus 4x square y minus y cube is not a homogeneous function of degree 3. Not a homogeneous function of degree 3. So what we have to do? We have to first write this thing, what they have told. Right? After doing this, put x is equals to lambda x and y equals to lambda y in f of x comma y. If you do this, you are going to get f of, which will be log lambda cube x cube 4 lambda square x square lambda y minus lambda cube y cube. Right? If you see here, lambda cube will come outside, that's right. That's correct, but this is entirely different. We wanted the answer should be in format lambda power some z into f of x comma y, but you can clearly see it is not coming out like that. So it is something different. If we simplify it further, it will be log lambda cube plus log x cube plus 4x square minus y cube, which is entirely different. So it f of lambda x comma lambda y is not equal to lambda power n f of x comma y. So it is not a homogeneous function. So if it is not a homogeneous function, we are not going to talk about the degree. Okay, it is not. If it is not a homogeneous, how can you verify the degree? If it is a homogeneous function, then you go for the degree. It is not a homogeneous function only. Now let's take some more example. The next example which we are going to take is if f of x comma y comma z equals to log xy yz zx the whole upon x square plus y square plus z square is a homogeneous function of degree 2 in 3 variables x, y and z. Now what we have to do, we have to write this. After doing this, put if you do this, what you are going to get? You will get okay. If you simplify here, you can do one thing. You can take lambda square common from here, like we did here from lambda square common. So I'm going to live with lambda square xy plus yz plus zx the whole by x square plus y square plus z square lambda square. You can clearly make out lambda square will cancel out and you are going to get this thing. Which is nothing but your f of x comma y comma z, which proves that f of lambda x comma lambda y comma lambda z. But you will say, where is lambda? Here it should be lambda. Yeah, here there is lambda, but you just need to observe it is lambda power 0, f of x comma y comma z. So it is a homogeneous function of degree 0, not 2. Okay, that is the thing which you should. Okay, in this type of question, student get confused that here there is no lambda, but there is lambda which power is 0. Okay, now let's move on to the last question which you are going to take on verification of homogeneous function. So the question which we are going to take is this question: if h of x comma y equals to lambda x 1 by 2 plus y lambda y power 1 by 2 the whole upon x power 1 by 3 plus y power 1 by 3 the whole by 1 by 2 is a homogeneous function of degree 1 by 2l in two variables x and y, right? So what do you have to do? hx comma y equals to this thing, x power 1 by 2 plus y power 1 by 2 the whole power x power 1 by 3 y power 1 by 3 the whole power 1 by 2. What you are going to do? Put x is equals to lambda x and y equals to lambda y in hx comma y. The moment you do that, you are going to get lambda x lambda y equals to lambda power 1 by 2 will come outside. Here you will be left with lambda power 1 by 2 plus y power 1 by 2 the whole upon x power 1 by 3 plus y power 1 by 3. You are going to get here lambda power 1 by 3 outside. So but it is the whole upon 1 by 2. So if you do that, if you move this up, what you are going to get? Here it is 1 by 2. Remember that. What you are going to get? Here it will be lambda power 1 by 2 minus 1 by 3 the whole upon x power 1 by 2 plus y power 1 by 2, the whole upon x power 1 by 3 plus y power 1 by 3, the whole upon 1 by 2. So here if they can simplify, what I am going to get, lambda power 1 by 6 into this x power 1 by 2 plus y power 1 by 2, the whole upon x power 1 by 3 plus y power 1 by 3, right, the whole power 1 by 2. So if you can see, if I take lambda outside, it will be multiplied by 1 by 2 and I am going to get lambda power 1 by 12, which we, and in the inside it will be h comma x comma y. So we have proved what we wanted, that lambda x lambda y is equals to this. So it is a homogeneous function of degree 1 by 2. So there can be this kind of degrees, okay, 1 by 12 like that. Students have sometimes confusion in that. Now if we, so we are going to study some new things, okay, which is this question which will teach us something new. Express u as x comma y equals to x power 4 minus 3x square y square plus 7x y cube as x power n f of y power x or x power lambda power n, sorry, here it should be y power n f of x by y if it is a homogeneous function of degree 4. So here they have told that it is a homogeneous function. So what I can write, u of x comma y is equals to what we can write? We can write it at x power 4 minus 3x square y square plus 7xy cube. This thing we can write. Now to convert it in this format, what we can do, divide and multiply by x power 4. So if I do that, its power will still be, degree will still be same, 3. Here you will get to know that this is this 7 y by x the whole. So here you can see it is nothing but f of y by x. Okay, so this is another way. Okay, if it is a homogeneous function, you can divide by some random value and get it the given equation function in this format. And if you want it in this format, you have to do multiply and divide by y power 4, this thing. So you will get the answer in this format, right? So which is just that means that you have got it, the function in this format. So this format is useful because we will use it while proving the theorems, Euler's theorem. So these things I have told, okay, I have taught you, I have taken some questions based on this, that if it is a homogeneous equation, how to deal with this, okay, these type of manipulations. So to teach you, I have taken this question. Okay, if it is a homogeneous function, you can multiply and divide by the highest power, okay, the constant power, and here the degree will be what, x power 4. You can make out degree, but you have to multiply and divide by highest degree, which is x power 4 and x power y, to convert it in this format. Okay, so we are done with the homogeneous function introduction. Okay, and in the next session we are going to do Euler's theorem. Till then, revise all this concept and see you in the next lecture. Thank you.